Okay, exponential review, unit 9, day 1. So, the parent function for an exponential function is f of x equals b to the x power, where b is a number. You might want to write that b is a number. If b is greater than 1, the function is an exponential growth and is increasing. If b is less than 1, the function is an exponential decay and decreasing. Okay, and we've talked about asymptotes before, but an asymptote is a line which the graph gets close to but never crosses, generally represented by a dotted line. Okay, let's just get into this. So we're going to graph these, and the way we're going to do that is we're going to make a t-chart. And we're going to have x and we're going to have y. On the x's, it's -2, -1, 0, 1, and 2. Every single time, those are your x values. Okay? So I'm going to plug in -2 to my function. So I have f of -2 equals 2 to the -2nd power, which is 0.25. So y is 0.25. Do the same thing with -1, get 0.5. Same thing with 0, which is 1, 1, which is 2, and then 2, which is 4. Okay, now we're just going to graph this. So at -2, it's at 0.25. -1, it's at 0.5. 0, it's at 1. 1, it's at 2. 2, it's at 4. And then we can just graph that line right there. Okay, now domain is my x values. X goes left to right, so that's all real numbers. Range is my y values. The lowest y value this ever gets to is 0, so this is y is greater than 0. End behavior, that's the as x goes to -infinity, f of x goes to what? And as x goes to +infinity, f of x goes to what? So as x goes to -infinity, f of x is going to 0, so y is going to 0. And then as x goes to +infinity, f of x is going to +infinity. Okay, my y-intercept here is 0, 1, because that's where it crosses the y-axis. And then my asymptote, that's always the same as whatever the range is, so that's y equals 0. Cool? Let's do this one. Same thing, we're going to make our t-chart. -2, -1, 0, 1, and 2. Plug those in. So we get 2.25 for -2. 1.5 for -1. 1 for 0. 0.67 for 1. And 0.44 for 2. Graph those, but -2, 2.25, -1, 1.5, 0, 1, 1.67, 2.44. And we can graph that. Now the domain, again, is x values. That's all real numbers. Range is the y values. The lowest this gets is 0, so y is greater than 0. And behavior, as x goes to -infinity, f of x goes to +infinity. And as x goes to +infinity, f of x goes to 0. My y-intercept is right there, so that's 0, 1. And my asymptote is the same as my range, so that's y equals 0. We'll save example C for class. Now this. This is the same that we were doing for sine and cosine when we were transforming like quadratics and linear functions and square root functions. This is the same thing. So h is the horizontal shift, which is your x value. K is the vertical shift, which is your y value. Then if a is negative, the function is reflected across the x-axis. If the absolute value of a is greater than 1, that represents a vertical stretch. And if the absolute value of a is greater than 0 and less than 1, that's a vertical compression. So if a is greater than 1, it's a stretch. And if a is less than 1, it's a compression. That's the biggest thing you've got to remember right there. Okay? So let's look at these. We're going to identify the parent function and describe the transformations. So on this one, the parent function is 3 to the x. And then that plus 5 is going to make it go up 5. For b, the parent function is 1/4 to the x. And the transformations vertically stretched by 2 because 2 is greater than 1, so it's a stretch. And then that minus 1 makes it go right 1 because it's the opposite of what we think. Okay, for c, parent function is 4/3 to the x power. The transformations, that negative makes it reflect over the x-axis. Plus 2 makes it go left 2. Plus 7 makes it go up 7. Parent function here is 5 to the x. Transformations, vertically compressed by 1/2. Right 4, that minus 4 makes it go right 4. And then down 2. Okay? Let's look at this example right here. So first, what's our parent function? It's 2 to the x. Transformations, we go left 5. So I'm just going to draw my t-chart. But I'm going to use just 2 to the x power. On the transformations, you don't use the horizontal transformation or the vertical. So your h and your k, ignore that. But say your parent function, or say you had f of x equals like 3 times 2 to the x minus 4 plus 3, or something weird. That would go right 4 and up 3. And then when I plug this into the chart here, I would just use 3 times 2 to the x power. That's the function I would use. Okay, if you have questions on that, we'll go over it more tomorrow, or ask me, come in before or after school and ask me. But we're just going to let f of x equal 2 to the x power. We're not going to work with the left 5 yet. Okay, so that's going to be f of negative 2, which is 0.25. F of negative 1, which is 0.5. F of 0, which is 1. F of 1, which is 2. And then f of 2, which is 4. Okay. And then my transformation, I went left 5. So that's going to be my new axis right there. I'm going to go left 5. I'm going to draw that new axis right there. Now, from that new axis, that's where I'm going to plot these points. So negative 2, 0.25, that's where that first point is. Negative 1.5 is right there. 0, 1 is right there. 1, 2 is right there. And 2, 4 is right there. Then we're just going to draw that. Now, my domain on this is my x values, so that's all real numbers. My range is the y values. So that's y is greater than 0 because y never crosses that line, never goes below 0. And behavior, as x goes to negative infinity, f of x goes to 0, and as x goes to positive infinity, f of x goes to positive infinity. The y-intercept is not super clear where it crosses the y-axis, so we're going to plug 0 in for x and solve this. So this is going to be f of 0 equals 2 to the 0 plus 5 power, which is 2 to the 5th power, which is 32. So my y-intercept is 0, 32. Then my asymptote is the same as my range, so that's just y equals 0. Okay, we're going to save that next example for class. Let's get to these last ones. So solving exponential equations, you're going to use the property of exponents to simplify each side of the equation. So like the properties of exponents, if your bases are being multiplied, so say you have 2 to the 4 times 2 to the x, that's the same thing as 2 to the 4 plus x. If you had 2 to the 4 divided by 2 to the x, that's the same thing as 2 to the 4 minus x. Okay, that's what that's talking about. So multiplication goes with addition, and then division goes with subtraction. Okay, rewrite the equation so both sides have the same base. Then the third step is to drop the bases and set the exponents equal to each other, and then one last thing, then solve. Okay, once you drop those bases, you're going to solve this equation. Maybe. All right. So let's look at example A. So we have 2 to the x plus 1 and 2 to the 9th. We already have the same basis, so this is easy for us. We're just going to set x plus 1 equal to 9. Solve for x, so you get x equals 8. If the bases are the same, hallelujah, we can just drop those bases and then set the exponents equal to each other. Now this one, the bases are all the same, but we have to use the property of exponents to rewrite this. So we're going to have 3 to the k plus 2 equals 3 to the 5k minus 1. So that's 3 to the 2k plus 2 equals 3 to the 5k minus 1. Now we have the same bases. We can drop those bases. You get 2k plus 2 equals 5k minus 1. If you move that 5k over, move the 2 over, you get negative 3k equals negative 3. So k equals 1. Cool? Let's look at this one. Now these ones are a little bit trickier because we have to get the same base. So 6 to the 2x minus 10, that's already simplified as far as we can go. 36, though, can be rewritten as 6 squared. So I'm going to replace that with 6 squared. So I have 6 to the 2x minus 10 equals 6 squared. Now we have the same base, so I can cancel those bases. And you just get 2x minus 10 equals 2. Add that 10 over, so you get 2x equals 12. And x equals 6. Voila. Okay, let's look at this one. 3 to the 2x, 3 is as small as we can get it. Now 27 is the same thing as 3 cubed. So I'm going to replace that with 3 cubed. So I have 3 cubed times the 2x plus 6 equals 3 to the 2x. Now I can drop those bases, set the exponents equally to each other. So you get 3 times 2x plus 6 equals 2x. So that's 6x plus 18 equals 2x. Subtract that 6x over, you get 18 equals negative 4x. So x equals negative 18 over 4, which is negative 9 over 2. And I want you to leave those as fractions. I don't want you to write the decimal. Okay? Let's look at E. Now this one, we're going to have to change both bases because 4 to some power will never equal 8. But 4 is the same thing as 2 squared. 8 is the same thing as 2 cubed. So I'm going to replace the 4 with 2 squared. I'm going to replace the 8 with 2 cubed. Now we have the same base. You can drop those. So that's 2 times 3x equals 3 times x minus 1. So that's 6x equals 3x minus 3. Subtract the 3 over, 3x equals negative 3. Divide by 3, you get x equals negative 1. Okay, this last one. So we need to get the common base. Now, this is something I don't know if you guys remember, but if you have a negative exponent, say, let's just work with 2. Say you have 2 to the negative first power. Anytime you have a negative exponent, it just drops to the denominator. So this is the same thing as 1 over 2 to the first power, which is 1/2. Okay, same thing with like 2 to the negative second power. That's the same thing as 1 over 2 to the second power, which is 1/4. Okay, 2 to the negative third power is 1 over 2 cubed, which would be 1 over 8, and so on and so forth. That just keeps going that way. Okay, so here we have 1/16. 1/16 is the same thing as 4 to the negative second power, because 4 squared equals 16, so 4 to the negative second power is 1 over 16. Now I can replace that, so I get 4 to the 2x times 4 to the negative 2 equals 4 to the 6x plus 18. Combine those on the left because they're being multiplied. So that's going to be 4 to the 2x minus 2 equals 6x plus 18. Those bases can cancel. You get 2x minus 2 equals 6x plus 18. Subtract that 6x over, you get negative 4x. Add the 2, you get 20. Now divide by 4, and you get x equals negative 5. Okay? Remember to take the quiz. I will see you guys tomorrow.